Alright guys, in this video we'll continue on 5.1, jointly distributed random variables. Let's take a look at what's going to happen if there are two continuous random variables. Let me pull out the marker. Let's take a look at the definition first. Let x and y be continuous random variables. A joint probability density function, of course, is also called joint PDF, f of x, y. So since we got two random variables, joint to a probability density function f of x, y for those variables is a function satisfying, of course, first of all, for being a PDF, it got to be greater than or equal to 0 always, and the double integration from negative infinity to positive infinity, f of x, y, dx dy is equal to 1. And that's another important property of a PDF. So in other words, just like the sum of all probabilities should be equal to 1. So in this case, since we are dealing with two continuous random variables, so we got to do the double integration here because we got two random variables and they are continuous. Then for any two-dimensional set A, the probability the outer pair x, y in set A is going to be equal to the double integration over A, f of x, y, dx, dy. So just like very similar to what we learned before. So if we are dealing with only one random variable, if it's continuous random variable, and if we want to find the probability x is greater than or equal to a, less than b, we use to integrate the PDF over a, b, dx. And that's how we find the probability of interval from a continuous distribution. Because it's continuous, we got to do the integration to find the sum of all probabilities. So the same thing here. So if we wanna find the probability the outer pair in the set A, we got to do the double integration of f of x, y, dx, dy, because there are two random variables, and that's why we need to integrate it twice, with respect to x one time and then with respect to y one time. In particular, if A is a two-dimensional rectangle x, y, such that x is between a and b, y is between c and d, then probability that the outer pair x, y in set A is equal to the probability x is greater than or equal to a, less than b, and y is greater than or equal to c, less than d. So this would be equal to the integral from a to d and then c to d f of x dy dx. So the reason why we put dy over here is because the interval of the inside integration is from c to d, which is the interval of y here. So of course you can just rewrite it like this: from c to d and then from a to b, f of x y. And this time it's going to be dx dy, because the interval of the inside integration is a to b, which is the interval of x, That's why we need to put the dx inside. Okay. All right, once this is clear, let's take a look at this. This is a kind of the explanation of the definition. So we can think of f of x, y as specifying a surface at head f of x, y above the point x in a three-dimensional coordinate system. So actually, I think you might say something like this in your calculus class if you are dealing with two random variables. So if you want to draw the graph of it, it's going to be three-dimensional, okay? Then the probability at outer pair x, y in set A is the volume underneath this surface, which is the surface f of x, y, and above the region A. Analogous to the area under the curve in the case of a single random variable. So as is showed here, actually, instead of calculating the area bounded by the interval of the random variable, in this case we're looking for a volume here, because since we're dealing with two random variables, so if we want to draw the graph of this function, the PDF here is going to be a three-dimensional graph. Okay, that's why we need to do the double integral to find the volume, which is the probability of a set A here. Okay, as what I say here. All right, so once this is clear to you, let's take a look at this example. I think the example will clarify everything from the definition. So it says a bank operates both a drive-up facility and a walk-up window. On a randomly selected day, let x is equal to the proportion of time that the drive-up facility is in use. At least one customer is being served or waiting to be served, and y is equal to the proportion of time that the walk-up window is in use. Then the set of possible values for x, y is rectangle D, which is equal to outer pair x and y, such that x got to be between 0 and 1, and y got to be between 0 and 1. Okay? Suppose, because both of them represents the proportional time. Since it's a proportion, so it's got to be between 0 and 1. Suppose the joint PDF of x, y is given by f of x, y is equal to 6 over 5 times x plus y squared. Of course, both x and y got to be between 0 and 1. So to verify this is a legitimate PDF. So based on what we just learned, we know that if we wanna verify if it's a legitimate PDF or not, we need to check two conditions. Number one, f of x, y got to be always positive, because it's a probability. For being a probability, it's got to be always greater than or equal to 0, which is over here, because based on the expression we got over here, we don't have a negative sign here, and since both x and y values are positive, so whatever x and y are, this whole thing is always greater than or equal to 0. So the first condition is satisfied. And then we need to check that the sum of all probabilities is equal to 1, which means the double integration in general, the double integration from negative infinity to positive infinity, f of x, y, dx, dy is going to be equal to 1. So we need to check if this thing is equal to 1 or not. So in that specific case, since both x and y got to be between 0 and 1, so it's going to be 0 and 1 here, 0 and 1 here, and 6 over 5 x plus y squared dx dy. Okay? Now, based on the property of integration, so we can actually split this into two parts based on the addition we have here. So which is the double integration of 6 over 5 x dx dy plus the double integration from 0 to 1, 6 over 5 y squared dx dy. Okay? So since actually we can just do this, do the regular calculation. So if we do the inside part, so the inside part here is from 0 to 1, 6 over 5x dx. That's the inside part. So if you do this, we just need to apply the power rule, which is what is that, 3 over 5x squared from 0 to 1. So this would be 3 over 5, right? Yes, it is 3 over 5. So this is the inside part. So if we add the outside part to it, so it's gonna be let me just put the outside part over here from 0 to 1 and then dy. And of course, let me just rewrite this thing here. So this would be equal to, let's just write down the outside part. So we know the inside part is equal to 3 over 5 and then dy. So this would be equal to 3 over 5y, 0 to 1, and this is equal to 3 over 5. Okay, that's how you find the integration of the first part here. So the second part is the same thing. I'll just do it on the other side here. Let me rewrite it from 0 to 1, 0 to 1, 6 over 5 actually, 6 over 5, what is it, y squared dx dy. So in the inside, since we're doing the integration with respect to x, so that would be let me just rewrite the outside part, dy, and that would be 6 over 5 y squared x, right? So if we do the integration with respect to x, we just consider the y squared part as a constant number, and then from 0 to 1, right? So this would be equal to from 0 to 1 and 6 over 5 y squared, because of 1, if we plug both 1 and 0 back into the x here, we got a 1 minus 0, which is just 1. And then dy. Of course, if you apply the power rule for this one, it's going to be 2 over 5 y cubed from 0 to 1, so which is 2 over 5. And if you add those two things together, will give us a 1 here. So since this thing is equal to 1, so this is a legitimate PDF here. So once again, if you want to check if a PDF is legitimate or not, you need to check those two conditions. Number one, if it's always positive, if it's always greater than or equal to 0, and if the double integration is equal to 1 or not. All right. So once this is clear, let's take a look at this problem over here. The probability that neither the facility is busy more than 1/4 of the time is. So since neither is more than 1/4, which means both of them got between 0 and 1/4, right? So in other words, in this case, we're looking for the probability that x is greater than or equal to 0, less than or equal to 1/4, and y is greater than or equal to 0 and less than or equal to 1/4. So of course, since we're looking for this probability, and we just need to integrate the joint PDF, which is given here. We just need to integrate this joint PDF on or over those two intervals. Okay, so from 0 to 1/4 and 0 to 1/4 dx dy. And then, so of course, you can just go ahead to split it into two parts based on the additive property. So that would be the double integration with respect to x plus the double integration with respect to y. No. The double integration of x plus the double integration of y squared. Okay. All right. So let's take a look at how to do this integral over here. The inside part, let me just read the whole thing. 1/4, 0, 1/4, and x dx dy. Okay, this is a d. Let me rewrite it. X. So since the inside part is integrating the x with respect to x, so it's going to be 1/2. This is 1/4 here. 1/2 x squared. From 0 to 1/4, and then dy. And then you just need to plug the 1/4 back into here. It's going to be from 0 to 1/4. This is 1/2 times 1/4 squared minus 0. So that would be equal to 1/32 dy. And that would be 1/32 y from 0 to 1/4. So that would be 1/32 times 1/4. So which is 1/128. So that's for the first part. And the second part is the same thing. I wouldn't do the calculation here again because it's just some basic integration here. And I gotta tell you this, you would definitely say something like this on the test. So if you forget how to do the integration, you got to kind of review on it a little bit, because you would definitely see something about integration on both the exam 2 and the final exam. Okay, the integration is very important for this class, especially for chapter 4 and chapter 5. Okay, so that's pretty much how we find this probability that both x and y are between 0 and 1/4. I wish it is clear enough to you. All right, once we know how to find the probability of interval from joint PDF, let's take a look at how to find the marginal PDF. So actually, they're very similar to the idea we went over in the previous video, just like the marginal PMF of discrete random variables. So the marginal PDF of each variable can be obtained in a manner analogous to what we did in the case of two discrete random variables. The marginal PDF of x, that's the value. X results from holding x fixed in the pair x and y and integrating the joint PDF over y. Integrating the joint PDF with respect to x gives the marginal PDF y. So over here, very similar to the idea we just went over in the previous video. So if you want to find the marginal PDF of x, you just need to integrate the joint PDF over y. Okay? Similarly, if you want to find the marginal PDF of y, you just need to integrate the joint PDF over x. That's so what you need to do. Okay? Now, once this is clear, let's take a look how to do it. So based on the actually, this is the continuation of the example we just went over. Let's just go back here. Let's take a look at how to do it. Let me just clean. What do we got here? Let me clean this all to make it look better. So now let's take a look at how to find the marginal PDF of x in this case. Find f of x, f sub xx. So that's the marginal PDF of x. So based on the definition we have, if we want to find the marginal PDF of x, we just need to integrate the joint PDF f of x y over y, right? So of course in this specific case, we know the interval of y is from 0 to 1. And then 6 over 5 times x plus y squared dy. Right? Actually, we can pull out the 6 over 5. So 6 over 5. And then integrate this thing with respect to y. Of course, we just consider x a constant number, so that would be x of y, and then plus 1/3 times the 1 cube. This is a power rule for that. And then from 0 to 1. And of course, this is equal to 6 over 5. We just plug the 1 back into here for y, x plus 1/3. Right? And minus, if we plug 0 back into here, this is going to be minus 0. And then if you want to distribute the 6 over 5 to the parentheses, it's going to be 6 over 5x, and then plus 2 over 5. Okay? So if you write the general form of marginal PDF of x down, so that would be f of x is equal to, what is it? 6 over 5x plus 2 over 5. This is a 4x is greater than or equal to 0, less than or equal to 1, right? What about otherwise? It's going to be 0, of course. So that's pretty much how we find the marginal PDF of x. So if you want to find the marginal PDF of y, just do the same thing here, but the only difference is you want to integrate the joint PDF over x, since the interval of x is 0 from 1 as well. So it's 6 over 5 x plus y squared, and then dx. So that would be equal to 6 over 5. So the integral of x with respect to x is going to be 1 over 2 squared plus x y squared, right? Because if we do the integration with respect to x, we just consider y squared as a constant number. And then from 0 to 1. And then we just plug the 1 back into here for x. It's going to be 6 over 5, and then 1/2 plus y squared, right? And then minus 0, of course, because if we plug 0 back into here for x, it's going to be 0. So, and then we just need to kind of simplify a little bit. That would be equal to, if we distribute this thing to the parentheses, it's going to be 6 over 5 y squared, and then plus, say, 3 over 5, right? So if you write it down like in general, it's going to be f of y, it's going to be equal to this thing, 6 over 5 y squared plus 3 over 5. Of course, for y is between 0 and 1. What about otherwise? Of course, 0. Don't forget the otherwise part, okay? If you want to get the full credits. All right, that's pretty much how to find the marginal PDF with the given joint PDF, okay? Now let's just take a look at the answer over here. So it's the same thing as what we got about there. So of course, if you want to find the marginal PDF of x, just need to integrating the joint PDF over y. So you do, since the interval of y in this case is from 0 to 1, so it's going to be from integration from 0 to 1, and this is the joint PDF 6 over 5 times x plus y squared. So after the calculation, you get this thing. I think this is the exactly same thing as what we get up here, right? 6 over 5x plus 2 over 5, same thing here. Similarly, and if you want to find the marginal PDF of y, just need to integrate the joint PDF over x, and then you will get this thing, which is exactly the same as what we get above there. And then of course, if you want to find the probability that y is greater than or equal to 1/4, so less than or equal to 3/4. So based on what we learned in chapter 4, we know that if we want to find the probability of interval, we just need to integrate the PDF over this interval, right? So do we have the PDF over here? Yes, we do over here, right? So we're looking for the probability y is greater than or equal to 1/4, less than or equal to 3/4. So we just need to integrate this, the marginal PDF of y over this interval 1/4 to 3/4. Okay? So I won't do the calculation again because it's a very similar, just like the basic power rule. So you got to answer like this. Okay, there's another way to do it. So if you need to solve a problem like this, I highly recommend you to do it like this way, as what we shown over here. Okay, you find the marginal PDF first and then find the probability. Okay, that's the way I recommend. And there is another way. This is kind of slightly different, just like kind of skip steps. So as what we mentioned before, if we want to find the probability, that y is greater than or equal to 1/4, less than or equal to 3/4, we don't have to worry about x, right? X could be any number it could be. So basically, if we put the integration of y outside from 1/4 to 3/4, and then since x could be any number it could be, right? The interval of x is from 0 to 1, and then f of x of y, and then dx dy. Okay? So the reason why we put the dx inside is because the interval of x is inside here. Okay, this is kind of skipping steps. Actually, they are not much different. It's because, like, let's take a look at what we did inside here. This inside integration is exactly the same thing as what we do for finding the marginal PDF of y. Okay? That's why I said I highly recommend you to find the marginal PDF first, like this, and then find the probability of interval of y. Okay? Of course, you can do it like this way, but there isn't much different, and you will not save too much work or time if you do it the second way. But it's easier to make mistakes. Okay. All right. If this is clear, let's move forward. Oh, actually, there's one more thing I would like to mention is that if we graph the region of the if we go back to here, so if we go back to here, if we want to graph the region of the support set of x and y here, in this case we're gonna have a rectangle. Actually, this is x and this is y, right? So there's 0 and this is 1 and this is 1 as well. So if both x and y got to be between 0 and 1, so the region for the positive values is got to be this rectangle, the shaded region here. So if we have something like that, it's got to be nice. Okay, this is friendly because the calculation in this kind of cases is kind of simpler, easier. But sometimes we will see something a little bit more complicated, which means that the region of the positive values is not a rectangle. It could be a triangle. Now let's take a look at this example here. But the philosophy is the same. So before really talking about this example, I will start it. Okay? I just want to let you know that you will definitely say something like this in homework, in the second midterm and the final exam. Okay, you would definitely say something like this. Just make sure this makes sense to you, okay? Now let's take a look at this question here. A nut company markets cans of deluxe mixed nuts containing almonds, cashews, and peanuts. Suppose the net weight of each can is exactly 1 pound, but the weight contribution of each type of nut is random. Because the three weights sum to 1, a joint probability model for any two gives all necessary information about the weight of third. Let x is equal to the weight of almonds in a selected can and y is equal to the weight of cashews. So of course, Sam, the sum of the three type is equal to 1, which means both x and y got to be between 0 and 1, and x plus y has got to be less than or equal to 1 as well. It cannot be greater than 1 because the sum of three types is equal to 1. Okay, now I think this is clear. So x is between 0 and 1. Y is between 0 and 1, and x plus y has got to be less than or equal to 1, okay? Because it cannot be greater than 1. So once this is clear, let's take a look at what's the region look like. So the region is going to be the region bounded by those three inequalities, right? Let's take a look at this. So first of all, x got to be between 0 and 1, and y got to be between 0 and 1. So if you want to say that, that's something like that. Right? This is if we don't have the third inequality here, just the first two, so we're gonna have a square, a rectangle, okay? But we get one more condition here: x plus y is less than or equal to 1. And I believe you learned how to graph this, the region bounded by this inequality, right? So if you want to shade the region bounded by this inequality, first of all, we want to find the straight line x plus y is equal to 1, right? So which means x is equal to negative x plus 1. So if we want to graph this straight line, we just need to find 2 points. When x is equal to 1, y is equal to 0, of course, because negative 1 plus 1 is 0. If x is equal to 0, y is equal to 1. So if we go to the graph over here, when x is equal to 0, y is equal to 1, which is this point here. When x is equal to 0 and y is equal to 1, this is point here. So the straight line between those 2 points is going to be the blue line here. And if we want to find the region bounded by those three inequalities, we need, if we want to find the region bounded by this inequality, since we have less than or equal to here, which means we gotta shade it down. We got shaded down, which is the shaded part over here, which is a triangle. Okay, not rectangle here in this case. And I gotta tell you this is the key part of this kind of problem, okay? You gotta know how to find the boundaries of the region. That's the most important part of this kind of problem, okay? Once you figure out the region, once you draw the region, it is easier to find the boundaries of the integration you will do in the future, okay? This part is very important. Okay, once we find the region, now let the joint PDF f of xy is equal to 24xy. So of course for x between 0 and 1, y is between 0 and 1, and x plus y is less than 1, or 0 otherwise, okay? This is a joint PDF. Now let's take a look at what we need to do here. Let's just read it over for quick. For any fixed x, f of x increases with y. For any fixed y, f of x increases with x as well. Yeah, of course, because both x, y are positive, right? Both x and y are positive, and we get a positive coefficient as well. So which means if fixed one value and if the other is increased, and the whole function is going to increase. So this is appropriate because the word deluxe implies that most of can should consist almonds and cashews rather than peanuts, so that the density function should be large near the upper boundary and small near the origin. So it's going to be the rectangle we shaded up here. So the surface determined by f of x, y slopes upward from 0 as x and y moves away from the other axis. So if we want to check if this PDF legitimate or not, first of all, we got to say if it's always greater than or equal to 0. I believe so, because both x and y are positive. You plug any number of any possible values of x, y, this thing is always greater than or equal to 0. So the condition 1 is satisfied. Let's take a look at if it's condition 2 satisfied or not. So based on the definition we went over before, we need to check if, in general, if negative infinity, positive infinity, negative infinity, positive infinity, f of x, y, dx, dy is equal to 1 or not. Okay, that's what we want to check. But this condition is kind of special. It's because we want to find, if we want to find this, we gotta find the boundaries of x and y, right? So if we have a rectangle, as what we have in the previous example, we can tell, okay, x is between 0 and 1 and y is between 0 and 1 as well. That case is easier, but this one is a little bit more complicated. So if we want to find the boundary of x and y, we gotta fix one variable and find the boundary for the other one. So for example, if we want to fix x, okay? If we want to fix x, x could be any number between 0 to 1 over here. And then the corresponding y value is going to completely depend on the x value. Which means, if, for example, if x is over here, let's say this is x1, the y coordinate is going to be between 0 to this. It cannot be greater than this y value here. And the corresponding y value is going to be equal to, let me rewrite down the graph of this line. So this graph is y is equal to -1, right? Negative x plus 1. Okay, which means when if the x value is x1, then the y1 would be negative x1 plus 1. Right? If x1 is over here, then the y value could be somewhere between 0 and this point, which is 0 to negative x1, or I'll just say 1 minus x1. Same thing, right? That's the interval for y. If x2 is here, if we let x is equal to x2, then y2 is going to be equal to 1 minus x2, right? Then the interval of y value is going to be from this origin to this point over here, which is the y value is going to be from 0 to 1 minus x2. In other words, if we fix x value, then the y is going to be somewhere between 0 and 1 minus x. X between 0 and 1, then y is going to be between 0 to 1 minus x. Because the value of y is going to completely depend on the value of x. Because this boundary here, this blue boundary here, okay, it cannot it cannot be outside the triangle here. Now once we got this, now we can just set it up, and we can see that the interval of x is from 0 to 1, the interval of y is from 0 to 1 minus x. Okay, because it cannot higher than this straight line over here. And then 24xy dy dx. The reason why we put dy here is because its boundary depends on x values over here. Okay? And then we just need to go ahead and find, let me see if we have the calculation here. Yes, actually we do have the calculation here. Let's just take a look at the calculation over here, because we have already done how to find the boundary of y. So once we got this, we have 0 to 1 for x and 0 to 1 minus x for y, right? So if we want to do this integration, we don't have to worry about 24x, because for the inside part we're doing the integration with respect to y, so we just consider x as constant number. So the integration of y is going to be y squared over 2, and from 1 minus x to 0. 0 to 1 minus x. And then we just need to plug this bound, the upper bound, back into y here. So it's going to be 24x times 1 minus x squared over 2. And of course, if you plug 0 back into here for y, you get 0 as well. You will get a 0 anyway. We don't have to write it down in the calculation here. And since we have we got a 4 down here, 24, so this will be equal to 12, and 2 will be cancelled out. So that would be 12x times 1 minus x squared. 12x times 1 minus x squared. So if you do the calculation, if you do this integration, I wouldn't do it over here, but if you want to prove it if it's true or not, you can just calculate this integration by applying the basic power rule, and this is equal to 1. So if this is equal to 1, we got to say this is legitimate. Okay, so once again, so the key point over here is to find the boundary of y here. Okay, the reason why the bound for y is from 0 to 1 minus x is because that the value of y completely depends on the value of x. Okay, the y cannot be higher than this straight line over here. So if x is over here, then the y is over here. And the y value in terms of x is 1 minus x, because this is a graph of y is equal to negative x plus 1. Okay, so this is how you find the boundary of double integration. You fix the one variable and find the boundary of the other variable. Okay, this part is very important. Once you find the boundary of the integration, the calculation part is relatively easier actually. So that's the main part to find the boundary here. I wish this is clear to you. So once this is clear, let's take a look at this example here. So to compute the probability that two types of nuts together make up at most 50% of the can, and of course, in this case, let A is equal to x and y, such that x is between 0 and 1, y is between 0 and 1, and x plus y is less than or equal to 0.5, as shown in the 5.3. I think that's the graph. Where is it? Oh, it's over here. So we are looking for the probability that the outer pair x and y is in the region A. First of all, we want to shade the region A, right? So the original region, the original graph is the triangle, x is between 0 and 1, y is between 0 and 1, and this the big triangle here is the original part, right? But what we're doing now, what we're looking for now is the probability that x and y is in region A. So we want to shade the region A first, right? So of course, x and y got between 0 and 1, between 0 and 1, there's nothing changed for that. The second part is x plus y is less than or equal to 0.5. So if you want to graph that, if you want to graph the region bounded by this inequality, we want to graph the straight line x plus y is equal to 0.5 first. So this is equivalent to y is equal to x plus negative x plus 0.5, right? So if we want to graph this straight line, when x is equal to 0, y is 0.5, and when x is at 0.5, y is at 0. So which is this point and this point, okay? So once we draw this line and we have a less than or equal to over here, so we got shaded down. So this shaded area is the region we're looking for. So if we want to find the probability that x and y in this region, we just need to integrate the joint PDF over this region here, right? All right. So if we want to integrate, the joint PDF over this region A, the shaded region here, the key point is to find the boundaries for both x and y. So you can fix one and find the boundary of x. So I usually fix x and find the boundary of y in terms of x. So let's take a look how to do that. So obviously we can tell if we fix x value, x could be any number between 0 and 5, right? And then the y value is that, for example, if x is here, y could be any number between this point and this point, right? Which means y cannot be higher than this one. If it is, it's going to be outside of the shaded region. So the key point is to find the y coordinate of this point in terms of x. We know that this line is 0.5 minus x, right? This is the line is, x plus y is equal to 0.5. This is equivalent to y is equal to 0.5 minus x. Which means if we take x here, the corresponding y coordinate is going to be 0.5 minus x. So which means the interval of y is going to be from 0 to 0.5 minus x. Once again, so in this kind of case, if we have a triangle region or a region which is not a rectangle or square, that's how you find the boundary. Okay, that's how you find the boundary. You fix x value and the interval of y is going to be from 0 to 0.5 minus x. So once you find out that, you are done like at least 60% of the problem, okay? Because that's the main part. Once we get this interval and this interval, and then after that, it's just like some basic calculations. And then once we have the boundaries, we just need to integrate the PDF over those two interval, 0 to 0.5 and 0 to 0.5 minus x. So the calculation is going to be very similar to the calculation we did up here. So I wouldn't do it again because the only difference is that we got a 1 and a 1 up here, but in this case we have 0.5. But the final answer is going to 0.0625. And this is how we find the probability of the outer pair in this region A. And this is a very important. Once again, you would definitely see something like this on the test or in the homework problems. And the key point of this kind of problem is to find the boundaries of y here. Okay, once you find the boundary of y, and then after that, just some basic calculations. All right. So once this is clear, let's take a look at the marginal PDF. Oh, actually, we have gone over the marginal PDF. Let's take a look how to find the marginal PDF in this case. Okay. So the marginal PDF for AMOS is obtained by holding x fixed at x and integrating the joint PDF of y. So basically, in this case, if you wanna find the marginal PDF of x, you wanna hold x fixed. So and then integrate the PDF over y. So if you like what we just saw above here, I will clear that. So as what we say over here. Okay. If you want to find f of x, the marginal PDF of x, we want to integrate the joint PDF with respect to y, right? So you want to hold x fixed. If x is fixed, what's the interval of y? The interval of y is going to be from 0 to 1 minus x. So you're going to integrate the joint PDF from 0 to 1 minus x with respect to y. What about you want to find the PDF of y? Of course, you want to integrate the joint PDF with respect to x, right? Which means you want to hold y fixed and integrate this thing with respect to x. If you hold y fixed, what's the interval of x? Okay, so since this line, let me clean it a little bit. So if you want to hold y fixed, once again, we know that this line is x plus y is equal to 1. Okay. And if you want to hold y fixed, you want to solve for x. So x is gonna be equal to 1 minus y. So which means for every y here, the corresponding x value is gonna be 1 minus y. Right? So if your y is here, then your 1 minus y is over here. Let's say y1, this is y2, and then 1 minus y2 over here. For the corresponding x value, of course. And then this is y3, and the corresponding x value is going to be 1 minus y3. So which means the x value completely depends on the value of y. So in other words, in this case, the if we hold y fixed, the interval of x is going to be from 0 to 1 minus y. So once this is figured out, we just do some basic calculation or the integration part to find the marginal PDF. So I wouldn't go over the calculation part again. Just tell you the idea, because the calculation is very similar. All right, that's pretty much how we find the marginal PDF of x. Over here, we integrate the joint PDF with respect to y, and we know if we hold x fixed, the interval of y is going to be from 0 to 1 minus x. Okay? And then we will have the marginal PDF is 12x times 1 minus x squared, of course. So when x is between 0 to 1, and it's going to be 0 otherwise. All right, so by symmetry of f of x and y on the region D, the marginal PDF of y is obtained by replacing x in x and f of x by y and y respectively. So since in this case this is symmetry, but usually if the problem asking both the marginal PDFs of x and y, so I would recommend you to just do the calculation separately as what I did over here. Of course, you gotta finish the integration part by yourself, because sometimes the joint PDF is not symmetry. In this case, the interval of x and y are the same, both of them between 0 and 1, but sometimes the interval of x and y are different. That means that the PDF is not, the joint PDF is symmetry, so we cannot find the joint PDF of y based on the symmetry. So once again, I will highly recommend you to calculate the marginal PDF separately, like what we did over here. All right, that's pretty much all about this video. So once again, the key point of this kind of problem is to find the boundary point here and here. All right, wish that makes sense to you.